The universe is a mystery full of secrets. Since the dawn of mankind, humans are in a constant pursuit to explore the cosmos. Each small discovery of this universe made the humans more curious and determined to explore and find the truths about their own planet and the world beyond. Today, the advancement in technology has made it possible to see the light that left its source long ago. The very faintest, farthest galaxies are now visible. The most powerful observatory ever launched was the Hubble Space Telescope. After floating in space for 2 decades, NASA has recently launched its latest and more powerful infrared observatory. The ambitious Space Observatory took off from the European Spaceport launch site in French Guiana on the 25th of December 2021. As the project had been first envisioned in 1996, the cost of the JWST had overrun from $0.5 billion to almost $10 billion. The telescope is named after one of NASA's early administrators, James E. Webb, who oversaw the creation of the Apollo program in the 1960s. It took no time for JWST to start making history. In a new paper released on the 20th of July 2022, a team of scientists claimed that the JWST had captured the oldest galaxy we've ever seen. That galaxy, named Glass Z13, existed when the universe was just 300 million years old. This galaxy is 13.5 billion years old, which researchers believe is the oldest galaxy ever detected. The previous record was by the Hubble Space Telescope, which detected GNZ11 in 2016. It is located at 13.4 billion light-years. According to NASA, GNZ11 was formed when the universe was only 400 million years old. The JWST has an extremely sensitive near-infrared camera that has allowed it to see the universe in a totally new light. NASA says the James Webb Space Telescope can peer even further into the universe, discover galaxies as far back as the first few 100 million years after the Big Bang. This will help astronomers understand more about the evolution of the universe throughout the ages. The James Webb Space Telescope has also recently captured the recordable oldest galaxy ever observed. The name of the galaxy is GNZ13, which was formed merely 300 million years after the Big Bang. The James Webb Space Telescope is an orbiting infrared observatory. It is more powerful, sensitive, and efficient than its predecessor, the Hubble Space Telescope. It has a longer wavelength coverage and ability to detect longer wavelengths that enables it to look much deeper into the beginning of time. Today, the Webb telescope has allowed scientists to hunt the unexplored corners of the universe. James Webb's telescope has the ability to look through the dust clouds where stars and planetary systems are forming today. The telescope has a primary mirror broken into 18 separate segments. The mirrors are gold-plated and expandable. This design was devised primarily so that the telescope could easily fit in the rocket. When the scope reached its designated orbit, the mirrors are expanded in space to absorb light. JWST will always be facing the sun. On that heated side, the telescope has a solar panel that is constantly gathering sunlight for power. Webb has a 5-layer sun shield, which is also retractable. The sun shield attenuates heat from the sun more than 1 million times. The installed cameras and spectrometers have detectors that are highly sensitive. Commenting on the accuracy of the camera of the telescope, Chief Engineer Charlie Atkinson said, "Its pointing accuracy is equivalent to firing a bullet from Washington and hitting a coin on top of a tower in Los Angeles." The James Webb Space Telescope, colloquially known as Webb, is operated primarily by NASA. NASA provides the bulk of the funding, along with the European Space Agency, or ESA, and the Canadian Space Agency, CSA, as partners. The James Webb Telescope is located at a point further from the Earth than the Hubble. The Hubble orbits at an altitude of around 570 kilometers above the Earth's surface. The Webb Telescope was launched towards the Lagrange point, which is between Earth and the Sun. The Webb Telescope orbits around the Earth and Sun at the Lagrange point. The advantage of this point is that the gravitational pull between the Earth and the Sun balances out, so the telescope can stay there easily for a longer period. The Webb Telescope is also studying the atmospheres of planets inside and outside of our solar system. The first image from the telescope was revealed by US President Joe Biden on the 11th of July 2022.
America is defined by one single word: possibilities. I want to thank the team at NASA. And now let's take a look at the very first image from this miraculous telescope.
It was of a galaxy cluster known as SMACS 0723. According to NASA, this cluster of galaxies was formed 4.6 billion years ago. The James Webb Telescope is also able to study planets around the stars in our own galaxy, examining their atmosphere and any signs of life. The telescope has a variety of scientific goals. They include examining nearby exoplanets, studying the earliest stars, observing supermassive black holes, and looking for signs of cold dark matter. It'll be used to study young galaxies and answer questions about how galaxies assemble and peer through clouds of dust to watch stars being formed. But it'll also look much closer to home, studying objects within our solar systems such as Mars, the gas giants, Pluto, and even some asteroids and comets. The reason that no one has seen the epoch of galaxy formation before is that the ancient starlight, after traveling to us through the expanding fabric of space for so many billions of years, has become stretched. Ultraviolet and visible light spewed by the farthest stars in the galaxy stretched to around 20 times longer wavelengths during the journey here. This has changed the visible light to mere infrared radiation. This is what differentiates the Webb scope from its predecessor, the Hubble. As the universe is expanding rapidly, the light emitting from distant planets and stars has been stretched to such an extent that it now lies in the infrared spectrum. So, only an infrared-focused telescope is capable to peek into the galaxies which are still undiscovered. Webb uses mirrors that capture 6 times more light than the Hubble telescope. The cameras capture images with a 15 times wider view. Hubble orbits the Earth at an altitude of 340 miles. Webb will be positioned out in space, roughly 4 times farther away from the Earth and the Moon, for maximum light gathering. There are a lot of mesmerizing photos James Webb's telescope has captured so far. This allowed us to take a peek at the wonders of the universe. One of the most famous discoveries captured by the telescope is the Cosmic Cliffs. This is a landscape of mountains and valleys speckled with shining stars in space. Southern Ring Nebulae was also captured by the camera. It is a star cloaked in dust. It is approximately 2,500 light-years away. NASA's James Webb Space Telescope has produced the deepest and sharpest infrared image of the distant universe to date. Known as Webb's first deep field, this image of galaxy cluster SMACS 0723 is overflowing with detail. Thousands of galaxies, including the faintest objects ever observed in the infrared, have appeared in Webb's view for the first time. This slice of the vast universe covers a patch of sky approximately the size of a grain of sand held at arm's length by someone on the ground. Webb Space Telescope also revealed Stephan's Quintet in a new light. This enormous mosaic is Webb's largest image to date. Covering about 1/5 of the Moon's diameter, it contains over 150 million pixels and is constructed from almost 1,000 separate image files. The information from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. With its powerful infrared vision and extremely high spatial resolution, Webb shows details in this galaxy group that were never seen before. Greg Robinson, Webb Program Director at NASA headquarters, says, "The beautiful diversity and incredible detail of the Webb telescope's images and data will have a profound impact in our understanding of the universe and inspire us to dream big." The James Webb Telescope is orbiting around one Lagrangian point, located on the far side of the Earth further from the Sun, called L2. In this position, as Earth moves around the star, the JWST will follow the planet almost in lockstep. No matter where Earth is on its course around the Sun, the JWST is guaranteed to be about 1 million miles away from us. The track that JWST is taking around L2 is actually fairly wide, stretching roughly the distance between the Earth and the Moon. But the observatory can't stay on that trajectory forever without some help. L2 is what is known as pseudo-stable. These objects that orbit this location will tend to drift away in one direction. So, the JWST will have to make small adjustments to its path over its lifetime. Every 20 days or so, the telescope will fire its thrusters for 2 to 3 minutes at a time to ensure that it stays on track in its orbit. Ultimately, these adjustments will determine how long the JWST can stay active in space. When the propellant runs out in the next 10 to 20 years, that's when the observatory's mission will end. The most distant galaxy ever observed by the Hubble telescope was the GNZ11. This galaxy was formed when the universe was only 400 billion years old. Breaking this record, the Webb telescope captured even a farther galaxy, the GN Z13. This galaxy is even younger than the GN Z11. As per scientists, the surface of the last scattering is 46 billion light-years away. This is the furthest galaxy we can observe. Some experts are even calling it the edge of the observable universe. Now that the James Webb telescope is slowly showing its potential, the next questions are how much farther back in time can the James Webb telescope see, and whether it will be enough to discover the very first galaxies that existed, perhaps just 100 million years after the Big Bang. Such a discovery would require a large dose of luck, since it would rely on fortuitous gravitational lensing to bring primordial galaxies into view. The James Webb telescope is more than just a telescope. It is a time machine that will take us back to the dawn of the universe. Some of the questions these galaxies will answer haven't even been asked yet.